In this section, we are going to start looking at absolute value inequalities. Yesterday, we did absolute value equations. Today, we are going to look at inequalities. So essentially, it's going to have a greater than or less than symbol in between the two sides of the equation. So just to recall here, to remember a couple of things, absolute value is the distance away from zero, and the distance is always positive. However, with inequalities, there are many correct answers to make an inequality true. So for instance, there's many answers that would make x is less than 2 true. There's like an infinite number of numbers we could come up for that. So when we have inequalities, they're just a little bit different way that we have to solve. So if you're solving an inequality with absolute value, you solve it differently based on whether or not it is a greater than problem or a less than problem. Let's start by looking at greater than or equal to. And our steps are going to be very simple. So these are steps that you might want to keep in mind, okay? So the first thing you're going to do is isolate your absolute value. Just like we did with the equations yesterday, you want whatever is in the absolute value to be all by itself on one side of the equation. And when you're using greater than, just to remember that the number over here, the number, can be negative since there are positive values that are greater than a negative value. So even if this number over here is negative, that's okay, because in that instance, there are numbers greater, say this was -5. There are numbers that are greater than -5 that are positive. So keep that in mind. So it's okay with greater than to actually have a negative number there for your number. Okay, and then you're going to rewrite using two inequalities. Sound familiar? That's what we did yesterday. We're going to rewrite using two inequalities without absolute value symbols, just like you did with solving equations. One of them is going to be using greater than, the other one is going to be less than. So the first one that your inequality that you will write is going to be your absolute value expression is greater than or equal to whatever your number was on the right. Your second inequality is going to be whatever was in your absolute value is less than the negative. You're going to switch the symbol and the sign. So the first inequality is just the same as the original problem without the absolute values. The second one is going to be the absolute value is you're going to flip the symbol and you're going to flip the sign. So then you're going to, step 3, there's lots of steps here. You're going to solve each inequality separately. You're going to graph each inequality on a number line, and then we are also going to write using interval notation. Remembering using interval notation, we have soft parentheses and we have brackets. The brackets are going to be when you have things that are equal to, and then the soft parentheses are going to just be like less than, or excuse me, just with greater than, since that's the category we're in. Okay, and also remember that the soft parentheses are also used for infinity. Okay, so let's start out nice and simple here. Okay, so we have the absolute value of x plus 2 is greater than 9. First thing that I note is that it is a greater than symbol. Okay, so that's what I'm paying attention to here, is that I have a greater than symbol right here. So I know that I'm going to need to write two inequalities. My first inequality over here is going to be x plus 2 is greater than 9. Same thing, or like it says right up here, that would be the blue one we have up here. The expression x plus 2 is greater than our number, which is 9. The second one is going to be x plus 2. Switch the symbol, switch the sign. Okay, so when we're done, our inequality over here on the left, if I subtract 2, I'm going to have x is greater than 7. And this one over here, I'm going to have x is less than -11. So if I subtract 2 on this one, I'm going to have x is less than -11. Okay, so then we've solved it. So here's one inequality. Here's the other inequality. We're going to put those on a number line. And to be honest, I'm just going to make my number line very simple. I'm going to have -11 here, and I'm going to have +7 here. And then there's all the numbers in between, but really we're just worried about those numbers. It's a greater than, not greater than or equal to. So our first inequality, x is greater than 7. We're going to put an open dot at 7. And anything greater than would be anything to the right. And then the other one is x is less than negative 11. We have an open dot because it does not have an equal sign. And everything to the left. Okay, and then our last step is going to be to write it as an interval notation. So if we read our graph from left to right, if we read from left to right, if we're coming across here, my graph started at negative infinity. Okay, and an infinity always has, excuse me, a soft parentheses, and then it stops at negative 11, and that also has a soft parentheses. And then it also is at, we start again at 7, and we go to positive infinity. So that's our interval notation. And just something to note that since either of these work, the negative infinity to negative 11, or we're going to put an or in between the two. Okay, so we could also put an or here also. So x plus 2 is greater than 9, or x plus 2 is less than negative 9. Okay, so let's just kind of try another one here. This one, okay, so this one we have to get our absolute value by itself. So the first thing that I'm going to do is add 2. And I'm going to have the absolute value of 3x minus 1 is greater than or equal to 11. The greater than tells me I'm going to write 2 separate inequalities. Okay, so I'm going to have the exact same thing first. 3x minus 1 is greater than or equal to 11. Or the other one is 3x minus 1. That's the exact same. Switch the symbol, switch the sign. And then if we add 1 to both sides on this one, we'd get 3x is greater than or equal to 12. X is greater than or equal to 4. So there's one of them. Or if we add 1 to both sides, we get 3x is less than or equal to negative 10. If we divide by 3, we get less than or equal to negative 10 thirds. And on a number line, negative 10 thirds is negative 3 and 1/3, roughly. Okay, so if we are just focusing on those two places on our number line, okay, we would have, here would be negative 10 thirds. That's going to be negative. And then over here we have 4. And again, we have numbers in between those two. So since it's an or equal to, we are going to have closed dot. Close dot. If we look at the 4, x is greater than or equal to 4, means that we are going to go in that direction. X is less than or equal to negative 10 thirds means we are going in that direction. So when we write it in interval notation, we go from negative infinity and we stop at 4. The 4 is an or equal to, so we are going to have a hard bracket, or again, another hard bracket, negative 10 thirds to positive infinity. And again, infinity always has a soft bracket. Okay, so let's take a look. We'll do one more here. We've got 3x plus 1 plus 5 is greater than 1. So I notice, first of all, yes, it's a greater than, so I'm going to write 2 separate inequalities. So I'm going to subtract 5 first. I'm going to have the absolute value of 3x plus 1 is greater than negative 4. Now, yesterday when we did equations, we said that an absolute value could not equal a negative number. However, if we think logically on our number line, there are a whole bunch of numbers that are greater than negative 4 that are positive. So in this case, when we have a greater than, it is okay to have a negative number. Okay, so we are going to go ahead, excuse me, and we are going to write our equations just like we did before. We're going to have 3x plus 1 is greater than negative 4. We're just going to write it exactly the same. And then we're going to have 3x plus 1 switch the symbol, switch the sign. And if we subtract 1, we get 3x is greater than negative 5, and then x is going to be greater than negative 5/3. Okay, so there's one of our inequalities. If I subtract 1 here, I get 3x is less than 3, x is less than 1. So there's our two inequalities. Okay, so let's look at that on a number line. Okay, negative 5/3 is approximately negative 1 2/3. Okay, so if we have an idea of where that's at. So on our number line, let's get, here's negative 5/3, and here is 1. We have an open dot, and it's less than, so it's going to go this way. And then negative 5/3 is greater than, oops, there should not be an or equal sign right here. Right here, there should not be one. Hang on. I don't know why it won't let me erase that, but there we go. That was my mistake. It's an or equal. There should not have been an or equal to. And then negative 5/3 is greater than. And if you notice on this one, if you look at the other two, right, they both had their values and they went in opposite directions. Most of the time, greater thans are going to go opposite directions. So most of the time, greater than or equal to will go opposite directions. However, this example, they crisscross, which means if you shaded in everything that we have here, we would shade everything going this way, we would shade everything going this way. We pretty much have the entire number line shaded in, which means we would have from negative infinity to positive infinity as an interval, because all the answers would work. Okay, so greater than, remember, means you write two separate inequalities where you flip the symbol, flip the sign. Okay, next we're going to look at less than and see how those work. Okay, so less than or equal to, again, you're going to do the same thing. You're going to isolate the absolute value, okay, just like we have in all of our other steps, except step 2 is a little bit different, okay? You are going to rewrite the absolute value using a compound inequality, okay? That means you're going to have your expression in the middle, you're going to have your negative number value on the left, and your positive number value on the right. Note that the inequality symbols all go, they both point, they're less than, and they point towards the smaller number, and the negative number is on the left. You're going to solve by using inverse operations on all three parts. And just like when we talked about weird situations, when solving right here, okay, when using less than, the number that you're taking with the absolute value cannot be negative, because all values that are less than a negative are also negative. When it was greater than, there was going to be numbers that were greater than that value. Anything less than a negative is also a negative. So you cannot actually have less than a negative number. So let's take a look. Oh, and then you're going to graph it on a number line, and then you're going to write your answer in interval just like before. So we have x. The first thing I'm going to look at here is I note that it is a less than or equal to, whoops daisies, I didn't want to cross that out, I wanted to highlight. I notice that it is a less than, which means I am going to write with a compound inequality. Compound inequalities are simple, okay? We put our expression in the middle, so we are going to put x minus 4 in the middle. We're going to put both of them pointing in the same direction. 8, we're going to put a negative 8 here and a positive 8 here. Okay, so all that means is that this value of x minus 4 is between negative 8 and positive 8. Okay, so we need to see what those values of x can be. So here's the tricky part. When you have a compound inequality, if you add 4, you have to add 4 to all of the parts, which means you're going to have negative 4 is less than or equal to x, is less than or equal to 12. What this says is x is between -4 and +12. So thinking logically on your number line, if here is -4 and here is +12, we have a closed dot because it's or equal to. Our values that work are between -4 and 12, which means we are going to highlight between -4 and +12. And then as a interval, okay, well, it includes -4, so as an interval, we're going to have a hard bracket. We're going to go -4, and it stops at 12, and another hard bracket. So there's our interval, there is our graph, and there are our inequalities. Okay, let's look at another one here. So this one is a little bit trickier because we do have to get that x plus 3 by itself first, which means we're going to need to subtract 5 from both sides. And notice a less than. Less than means compound inequality. So I'm going to subtract 5, and I'm going to have 2, and the absolute value of x plus 3 is less than 6, and then I'm going to divide both sides by 2. So we have the absolute value of x plus 3 is less than 3. Okay, oops, absolute value there, forgot to close that off. We are going to write it as a compound inequality. So x plus 3 is going to be in the middle. Both of our symbols are less than. They are both pointing in the same direction. The negative value goes on the left, and the positive value goes on the right. And then we have to just make sure whatever we do to one part, we do to all of them. So we're going to have -6 is less than x is less than 0. So there's our compound inequality. Okay. On our number line, it's a less than, so we're going to have, here's our -6, here's our 0. It does not have an equal sign, so we're going to have an open dot at -6, open dot at 0. X is between -6 and 0, which means we are going to shade between our two values. Okay, so there's second example. Our last example, less than, okay, so we know that if it's less than, that means we should be thinking compound inequality. However, if we look back up here, when using a less than, the number, in this case, which is -3, cannot be negative because any value that is less than -3 is also going to be negative, and the absolute value of that number cannot be negative, which means on this one, there's going to be no solution, and that is because absolute value can't be negative. Oops, that says negative. And all values less than -3 and all values less than -3 are also negative. So in this case, there is no solution.